Hi students, this is your hints video for lesson 10.3 on experimental and theoretical probability. So our first few problems give us this bar graph, and we need to find the experimental probability of certain events. So on number 8, we have the experimental probability of spinning a number less than 3. So if we look at our bar graph, it looks like we spun a 1 8 times and we spun a 2 6 times. So that's 14 outcomes for spinning a number less than 3. And then we need to add up how many total spins we have. So 8 plus 6 plus 9 plus 11 plus 9 plus 7. So we'll add those up. And when I added those up, I got 50. And we can simplify that to 7 over 25. So that's the experimental probability. Based on the results of this experiment, 7 out of 25 times we spun a number less than 3. All right, then we have this problem with the lettered tiles and a board game. You choose the tiles shown, 7 letters. How many of the 105 tiles would you expect to be vowels? So we can look at the experimental probability of choosing a vowel. There's 1, 2, 3 vowels, so 3 out of 7. And then we really want to see how many vowels should there be if there's 105 tiles. So we can just multiply 3 7s times 105, and that will give us the expected number of vowels. All right, I have number 14 for you here as well. It says there's a package of 20 assorted thank you cards. You pick the 4 shown, and we want to know how many of the 20 most likely have flowers on them. So out of the 4 we picked, there's only one, this one here, that has a flower on it. So 1 out of 4, and we can multiply that by the 20 cards to figure out how many cards out of the 20 we would expect to have flowers. All right, next you have several problems with this spinner. Now we're working on theoretical probability, so not the results of spinning the spinner, but just what we would expect based on the different outcomes that are available to us. So we want to write our answer as a fraction or a percent rounded to the nearest tenth. So the probability of choosing red, there's 2 reds out of 6. So that's 2 out of 6. We can round that to 1/3. The theoretical probability of spinning red is 1/3. We could also write it as 33.3%. All right, this last problem I'm going to do with you, we're comparing experimental probability based on the results of spinning a spinner with theoretical probability by looking at our outcomes. So our theoretical probability of spinning a 4 would be, we would expect 1 time out of every 5 spins. There's 5 outcomes. One of those outcomes is a favorable outcome of spinning a 4, so that's 1 out of 5, or we could call it 20%. The experimental probability, it looks like we spun a spinner 37 times. We got a 4 out of, it says we spun it 200 times, so 37 out of 200. If I divide 37 by 200, I get 0.185, that's 18.5%. So that experimental probability is close to the theoretical probability. And you have a few more examples like that where you're going to compare the theoretical to the experimental probability.